I'm going to briefly talk about the assessing normality, which means I try to find whether a distribution is really a normal distribution or not, because we check about the normality. Okay. You know what is a normal distribution? Bell-shaped, symmetric, right? And when we try to assessing normality, there's so many different ways. The first one is always, right, histogram. If you have the data set, you draw histogram, and then the histogram look like a bell-shaped. Of course, there's all the bars here, right? All the vertical things like that. If you have something looks like this, then you're going to be pretty happy and say, hey, it looks like a normal distribution. Okay, so that's the first method. That's the easy way that something you can do. All right, and number 2 is called a normal quantile method, or normal, we also call that like a normal quantile plot. It means graph. Okay, what did that mean is if you have a data distribution looks like a normal, and looks like this, okay, bell-shaped, and if you graph this normal quantile plot, you are going to get a straight line. If it's not, then it's not normal. I give you a very, very quick example to tell you what does that mean, and then I think we just stop here, because later there's going to be a lot of other different ways to check whether a distribution is normal distribution or not. However, in this class, I will just briefly touch it, and I will not ask you to do it. And in later, I think in this chapter and the next one, the confidence interval and the hypothesis testing, for the normality check, if you need to do it, if the question asks for it, I am going to just assume that is normally distributed. So I will let you know by that time. All right, now let's work on this normal quantile plot. What does that mean? Let me give you one data set, okay? The data set I give you is this. It's 0, 2, 3, 5, 20. And if you draw, here's 0, 3, 4, 5, 6, 7, 8, 9, 10. So let's see, each unit we call that 2. So you have a 2, right? You have this, that's 2. And then you have a 3, that's a 4, and this is a 6. You have a, and you have a 20. It's not normal at all. It's almost like a uniform, pretty close to that here, but it definitely is not normal. So how do we do the normal quantile plot? And this is your x. There are 5 numbers. So I will say there's 100% of the data here. So let's see. If I cut things here, I would say here it takes about 20%. So from here to the left, I'm going to say 10%. All right. Therefore, for 2, that's corresponding to 30%. And 3, that's a 50%. That's what percentage of the data less than that. So what is the z-score? Equals what? So the area, or the probability, the area to the left of it is 10%. So I find the corresponding z-score basically. If you look at the table, then you should be able to use the negative z-score table and try to find the probability very, very close to this. Okay, 0.1, because that's 10%. Okay, I did that on my table. I don't have the table right in front of me, but I got that z-score is negative 1.28. Okay, and the next one for this 2 corresponding z is to this, the normal, okay, the area to the left is a 30%, then this z-score is negative, I believe I got it was negative 0.52. All right, and then the next one for 30, which is the right in the middle, so that corresponding z-score, 50% of the data less than that, so that corresponding z-score is 0. Okay, so I can have this. I can have x and a z. X is 0, 2, 3, 5, and 20, and the z-score is in the middle is a 0, so here's a negative 0.52, here's a negative 1.28, and the other side is just a positive 5.2 because this is a 30% of the data less than this, and so 75% of the data less than positive 0.52, and here is 1.28. Treat this as a y, okay, in the y-axis. So you're going to have here's x, and this is your z-score, and then here's a 0. Again, here's a 20, right? We need 20, so here's a 10, here's a 5, here's a 15, and that's 1, 2, 3, 4, roughly 1, 2, 3, 4, 5. All right, now this is this is positive 1, positive 2, negative 1, and here negative 2. We're gonna plot this 0, negative 1.28, so that's this point. I want to use different color. So I get this point here, and when x equals 2, which is here, and I have a negative 0.52, so it's about here. And when x equals 3, I get a 0. When x equals 5, I get a positive 0.52, and when it's 20, I get a 1.28, slightly more than that. Okay, so if you connect them, see that goes from here. It's already getting slower. And so that goes from, well, this is not a straight line. If this is not a straight line, then this is not a normal distribution. As easy as that. If you have the data set comes with like a lot of numbers, let's say 100 or 300, or a lot of numbers, you can either get the histogram or a lot of software. Later I'm going to show you how to do this in the software. Then you're going to get the each number and corresponding to some kind of a percentage. What's the percentage of the number less than that? What percentage of the data less than that? And find the corresponding z-score. When you graph, you get a straight line. That's a normal. If it's not a straight line like this, it's not a normal. As easy as that. Again, I will not leave homework for this, and I just briefly talk about that just let you get a little idea about what is going on. But in later, I would just totally ignore that unless when we go to like advanced level of statistics, and then we're going to focus on this. And also we're going to learn some other methods like using the chi-square or using other methods to determine the normality. Okay, so this is a short course.